If the directions say graph, 3 is less than x, you need to pay a little bit more attention. Because normally we would look at the less than and we would think, hey, I want to graph everything less than, and that would normally mean a parenthesis and everything that way. What I'm going to show you today is that that's not exactly true with the way that they've given us this inequality. If I were to put 3 on a number line and do a real quick graph, I might think, okay, less than goes that way through my 3 and shade my arrow and I'm done. But let's think about this answer. 3 is less than x. When I'm asked to graph, what I'm asked to graph is all values for x. X should be anything within the section that I've shaded to make this inequality true. See that number 2? We shaded over it. Would 2 make this inequality true? If I replace 2 where the x was, is this true? Is 3 less than 2? No. The reason I can't just graph this in the way it's written is because that I've been asked to graph values for x. I was not told that x is less than 3, which is what I graphed. I graphed x is less than 3, anything smaller. What my inequality said was that 3 was less than x. So what we have to pay attention to when we graph is where the variable is. In an inequality, you really want your variable to be on the left. 3 less than x has the variable over here on the right. So what I want to do instead is not figure out the relationship between 3 and x, but instead between the x and the 3. And it's just a simple little trick here. With some common thinking, you can figure it out. If I want the 3 to move over to this side of my inequality, and I want the x to move over here, I want to make sure that the comparison stays the same. In this problem, the 3 is smaller than the x. So I want to keep the 3 to still be the smaller one. And if you think about what the inequality symbol means, I need the opposite symbol to say that 3 is the one that's smaller. So yes, they wanted me to graph 3 is less than x, but my thinking should actually say, well, really, x is greater than 3. So when I put that on my number line, 3, 4, 5, a greater than actually is this symbol and everything larger. And now I can check that solution. They gave me 3 less than x, and I just shaded over 4 and 5, and all of the numbers larger than that. Let's check. Let's use the 5 to check. Is 3 really less than 5? Sure. Now I've got the correct graph. Let's look at one more example to make sure you've got it. What if they told you that -8 was greater than x? If the directions say to graph this, remember that I want my variable to be on the left. I want the x over here. I want the -8 over here. And so all I have to do is think. In my problem, I was told that -8 is the larger amount because it's bigger than my x. So here I still want my -8 to be the larger amount, which means I need to switch to that inequality symbol. So if I graph that, I'm down here in the negatives. I want everything that's x is smaller than -8. X being less than -8 is this symbol, and everything to the left. And again, I can check my answer because I said, well, hey, -9 is down here where I've shaded, so -9 would be a possible solution. If you go back up to your original problem where we had -8 was greater than x, and we let x be something like -9, -8 is a bigger value than -9. All you have to remember when you're given a graph like this is to make sure that you make your variable move to the left side, which means switching the inequality symbol before you graph.